with center O, and inside the circle there is a horizontal chord AB. A vertical line segment CP intersects chord AB at a right angle. Now let's write down the given information. Segment CP is 12 units long, segment AP is 3 units, and segment PB is 48 units. Our goal is to find the radius of the circle. We'll begin with the first method. Extend segment CP downward until it meets the circle again at point D. This gives us a complete chord, CD. Let's call the unknown segment PD equal to X. Now pay attention to the theorem we're about to use. The intersecting chords theorem tells us that when two chords intersect inside a circle, the product of the two segments of one chord is equal to the product of the two segments of the other chord. So we can write 3 multiplied by 48 equals 12, multiplied by X. Let's calculate the left-hand side. 3 multiplied by 48 equals 144. Now divide both sides of the equation by 12 to isolate X. 144 divided by 12 equals 12, so X equals 12. If you're enjoying this explanation so far, don't forget to like the video and subscribe for more interesting geometry problems. Now comes a very useful shortcut. Whenever two chords intersect at a right angle inside a circle, we can use the formula 4 multiplied by the radius squared equals the sum of the squares of the 4 chord segments. Our 4 segments are 3, 48, 12, and 12. So we write 4 multiplied by the radius squared equals 3 squared, plus 48 squared, plus 12 squared, plus 12 squared. Let's calculate each square one by one. 3 squared is 9. 48 squared is 2,304. 12 squared is 144, and the other 12 squared is also 144. Now, add them together carefully. 9 plus 2,304 plus 144 plus 144 equals 2,601. So we get 4 multiplied by the radius squared equals 2,601. Now here's something very important to notice. This means the radius squared equals 2,601 divided by 4. And since the square root of 2,601 is 51, the radius becomes 51 divided by 2, which is 25.5 units. Notice that this is not an integer, and that's perfectly acceptable because the given measurements naturally lead to a radius of 25.5 units.